We're going to move in this third exercise into stratifying your landscape. So you recall that cells can be assigned to a spatial strata. Kind of talked about that earlier in the day. So the idea is that you can divide your landscape into a number of zones, call those strata, and then you can tell the model to behave differently in each one of those zones or strata. So the idea is that you can have different model parameters depending on which strata your cell is in. And generally, we think of these strata as zones that don't tend to change at least quickly over time. And we think of states as things that are very, very dynamic, right? We've seen that already. They can change every time step. The strata, I would say when we first started developing our tools, the strata actually couldn't change. Back in the 90s, the software didn't let you change them. Then we realized with climate change that was untenable. And so now we allow you to change the boundaries of these strata over time. And you'll see why we do that at the end of this exercise. So STSIM currently supports 3 levels of strata, called primary, secondary, and tertiary. So the reason for having 3 is typically you want to subdivide your landscape according to different dimensions, depending on what's you plan to vary over those strata. So the primary strata is usually a biophysical stratification of your landscape. This is an example of some modeling work that we've been working on, that doing some modeling of carbon in this case across the entire US. And the backbone of that model is a primary strata that's these ecoregions. I think there's 90 of them or so for the US. And so these are ecological zones in which you believe that some of the parameters of the model, perhaps the species you expect to see, or the fire behavior, or the climates is a classic one, right? Maybe the soils are going to be somewhat similar and different from neighboring strata. So this allows you to set up your models to behave differently according to different strata, and so it's usually biophysical. Secondary strata is usually a management-oriented layer. So typically jurisdictional. Again, in this modeling example, we're on a very coarse scale. We're running the entire U.S. These are U.S. states. If we go back one, if you're modeling a tiny little area, maybe 40,000 hectares, this could be generated off of soil and moisture conditions. That's a very typical sort of thing to use to drive your strata. And the jurisdictions on a finer, smaller scale could be something to do with how you're managing landscape, maybe protected areas versus unprotected areas, or something like that, right? Something that distinguishes how you're doing private versus public lands. That's another classic example where you're doing quite different management techniques on one or the other. And so these strata usually drive differences in, say, your harvest level or your fire suppression and the models we've been doing, and so on and so forth. So that's the idea behind the strata. And so this exercise, you're just going to take the landscape, the model you've been working with up till now, and we're going to blow it up to a much larger landscape and stratify that landscape in this exercise. So I'm hoping it'll take maybe 45 minutes, give us 10 minutes to sort of touch base at the end. Any questions about strata before we start? So just one thing to note is when you're in this screen with all the transitions, sort of slipped in this idea of this proportion column here into this exercise. So basic idea here is just a field that's in there for a matter of convenience. ultimately the probability that your model is running with is always the product of the field that's called probability with the field that's called proportion. And if you don't have proportions in there, it ignores it and just uses the probability. So what's gone on here with the harvest is the actual probability. You could have put 0.95 in here and 0.05 in here. We've done exactly the same thing. But we added this column several years ago as a convention for these branching pathways where you have two pathways that have identical conditions for the from class. The to class is often different, and you might have actually measured the probability. This case for harvest, we're putting in ones, but this could have been fire here, and you might have a base fire probability for how much fire you think there is in this particular state class. And then you just want to use this column to branch that into, say, 90% of the time it goes one way and 10% of the time it goes another way without losing the original base probability in your record here. So that's the idea there. That's what's going on with that proportion column. You can ignore it if you want, just use the probability column. So that was one thing. When we looked at the results here, just add this. Can't remember exactly which. Really looking at the transitions, but you were looking at the amount of harvest, weren't you? So you guys were asked to do a chart like this, where you showed how much harvest there was in each block. And so one thing to note, these charts, really for transitions, there's never any transitions that occur in year time step 0. Remember, at the start of the course, I said convention is that year 0 represents the initial conditions on December 31st. So it's a placeholder to put in initial conditions. Transitions start in year 1. So you see that kind of happening, and you can get rid of that off your charts if you don't like to see that by just starting your charts for transitions right in year 1. But what you'll notice is we were asking 600 acres per year out of every block. Recall, we set targets here for 600 in every block. And you'll notice that we don't always get 600. So what was one of the questions in the, let me just look again. Question was, do some harvest blocks appear to harvest more timber than others? Why might this be? So any thoughts on that? I haven't been asking people questions in my course today because I find that tough online, but any thoughts from anybody on why the harvest is not 600 acres per year in all the blocks? Well, I'll answer you. It's because there just isn't enough old conifer forest in some of these blocks. Sometimes there is the beginning, like in block B, and then it runs out. Same in block E. I don't think there's any block that can sustain 600 acres per year for the entire simulation. But in others, they're simply, they all run out at different times. So in fact, what I did is I created a chart like we did before of the amount of area in conifer age 30 plus. So I did that by making sure that my, I can't remember what you were asked to do for age classes in this exercise. How many were you asked to do in your definitions? Back.
The ages were already preloaded, Colin,
Were they?
into the exercise, I think,
So
maybe.
they were set in, oh, I changed mine in the solution. So do you remember what they were? Anybody tell me? They were probably 20, 40, 60, 80, something like that. Is that right? Yeah. So I wanted to see exactly how much area was available every year to be harvested. So I needed to know, because if we looked in the model, remember we said that only area, if we look at the harvest transitions here, only, area cells only become eligible when they hit 30 years of age and they're conifer, right? So it was a little tricky to set that up to get exactly the amount of area that was in conifer, age 30 plus. But what I did is I went back to the definitions here. I changed the age groups to have a max of 9, 19, 29. I needed the max to be 29 so it would show me 30 and older in the next class. So that's what I ended up with. I created a chart kind of like this, where I said I want to look at the area. We've been through this a couple times now. That's in state class conifer. And now, because I've set up my ages, I can set it up, whoops, to be exactly 30 and older, like that. And that's the total area across my whole landscape that's eligible for harvest. So you can see we run out eventually of area, but I'm really interested in how much is in each block, so I can go up here and disaggregate further by harvest block. And I can say, well, that's my include. Go up to the disaggregate and disaggregate by harvest block. And I see this, and actually I probably have some blocks I don't need. Don't need the blank, really don't need the no harvest. But there we go. There's a chart of how much 30-year-old conifer there is in each block, and you can see some of the blocks are running out, like block E runs out in time step 8, whereas block B goes on to 14 and so on. So that's what's causing this. I'm not sure why block A is got so much variability in it. It's partly because we're showing plots over, if we set the Y min to 0, the plots seem to follow the 600 acres per year, more or less. So that makes sense to people? Any questions about, before we go to the bonus, the results we see there in terms of harvest, why we can't sustain it? No, makes sense. So, in this example, again, we were using Strata. Leo, I think you got a mute. I hear your keyboard. There you go. We were using the primary strata to give differential probabilities for different dynamics for fire and for transition into this grassland. We're using the secondary strata to differentially assign our harvest across the landscape. Let's look then at how I did the aggregated harvest. So the question again was, how can I make the harvest go to one block for 4 years and then for the next block for 4? Did anybody manage to figure that out? It's a little tricky. Ready to get to work?
I had a go, but I think it was hopelessly inelegant.
Well, did it? I mean, it doesn't really matter in the world of modeling as long as you got the harvest to come out right.
So I added year to the transition targets table, and then listed all the years 1 to 40, and then specified the amount for each block through time.
Right. That's the brute force way to do it.
Yep.
And in fact, if you were doing this in a script, you might do it the brute force way, right? If you're not concerned about typing, you might write a script that created that file. So let's just show you how you might do that. So I created a copy of, let's just take a copy of this scenario. I already have the solution here, but I'll copy it and go paste. And so here's my, aggregated second time. Okay, I've already done it once. And so we go over here and we want to do something with these targets. So Stephen was right. The first trick is we want to vary the targets by time step. So we've got to right click here, look at our optional columns, and here it is year. So somehow we want to tell it what we want to harvest every year. So I think if I got you correct, Stephen, you put in like, what's the first year? Year one, went like this.
Yeah.
Did you do a lot of typing in here, or did you find a quicker?
I did a lot of copy and pasting.
Yeah. So this is something I haven't shown you yet, is that you can right click on any grid in the STSIM. You got this export button, which is very convenient for this kind of thing. So it allows you to export to a CSV or to an Excel file. So if you have Excel installed, you can get any table of data in SynchroSim, actually it's a SynchroSim feature, out into Excel, where it becomes a lot easier to copy and paste. You got a lot of patience to do it. And so here I am. I could do what Stephen said, which was kind of go like this, you know, whoops. I didn't like that. Just a second. Copy. And so I could go year two. So I could start it like this. In year one, I might want to start in block A, so the other blocks all get 0, and this wants to be 3,000.
3,000. Yep.
And I could repeat that for year two. Did you have 40 lines, Stephen?
Yeah.
Yeah. And so on and so forth. You know, I could go repeat that for 3 and then 4, and then in year 5, I could, you know, let's just say I type those other ones in. I could paste these down here, and in year 5, I could just now switch it, put this to 0 and this to 3,000.
Stevens, did you do that by hand in STSIM, or you went to Excel? You exported to Excel?
So I just did it in STSIM, but I deleted all the 0 ones, so I only had 40 lines.
Okay.
Oh well, that
Oh, you're a patient man.
that would probably, if you did this, I don't know if you tried to.
Yeah.
It shouldn't have worked. If you did
No.
block A, 40 lines probably would not have worked, I wouldn't think. If you did this,
Let's have a look.
I bet you your model blew up in year 5. If you went like this and then went block B, and then put harvest. This is what I think you did, Stephen, right? You put the thing, it's actually 3,000, sorry.
I know I just lost the mouse on my screen, so I can't actually open and see what I did. No, I had each year, and I had 600 acres for block A for the first 4 years.
Okay, I think in the exercise we actually wanted it to be all 3,000 in one block. It doesn't really matter, but it was supposed to.
I thought it was okay, yeah.
Right,
Yep.
supposed to put all the harvest for 3,000 a year in block A for 4 years, then switch it to block B. But this won't work. Doing that kind of thing, and block C will not work. The reason that won't work is this quirk in SynchroSim or STSIM, where whenever you specify a line, like we do here, in year 1 for block A, it will hold that value. This is why it works when we go like, kind of like this. If we were to do this without the year in there, it would hold the harvest at 3,000, start it in time step 1 and hold it there for the next 20 years. So it's a nice, easy way for you to put in one line and have it run for 20 years with the same harvest, right? What you have to do in STSIM is it holds any value you put in there for a particular time step or block in this case, it holds it there until you tell it to do something else. So if I wanted it to do that for 4 years, and then in year 5, I wanted it to stop harvesting in block A, I'd have to explicitly tell it to go to 0 in year 5. So that would be telling STSIM, harvest block A for year 1. I don't have a record for year 2, so do it again, same for year 2, same for year 3, same for year 4. Year 5, it hits a record here, it says turn it to 0, hold it at 5, 6, 7, 8, 9, 10, all the way to 20 would be 0. This isn't quite what we want, but this would harvest 3,000 in block A and then down to 0. But what I can do is in year 5, I can say in block B, actually what I have to do probably up here is tell it what to do in the other 4 blocks, right? So in year 1, I'm going to put in block B, block C, block D, and block E, and the no harvest as well. I have to tell it in all of them what to do in year 1. Okay, so I go like this, and I have to tell it explicitly, set it to 0 in all the others. So if I do that, what's it going to do in year 16? What's it going to harvest?
It will do the same thing. Keep on doing it.
Right.
Block A.
It'll do block A for 3,000 and blocks B, C, D, E, and no harvest at 0 for year 1, and then it doesn't see a record in year 2, so it continues on and on and on like that. So if I wanted to change its behavior, I could repeat these. This is kind of the long-winded way to do it, to be really safe. I could say in year 2, tell it to do exactly the same thing, because I want it to harvest for 4 years, at 3 and 4, but those records are actually redundant because it would hold whatever I told it to do in year 1 for years 2, 3, and 4 anyway. What I can do is in year 5, tell it to do something different. So in year 5, I could say, turn block A to 0, turn block B now to 3,000, and keep the other ones at 0.
You actually don't need the last 4, Colin.
Yeah.
Because they're already set to 0.
Right. So I could do that, and this is kind of the, not quite the most elegant way, but probably the easiest way to not make a mistake is to do what I'm doing here, which is, in year 9 now, tell it, okay, block B is going to switch to 0, and block C is going to switch to 3,000. Something like that. But as Leonardo pointed out, if you really want to save keystrokes, in year 5, you actually don't need to 0 these 4 out because they were already set at 0 before, so they're going to continue on at 0. So the most parsimonious way to set up this example would be to change block A from 3,000 to 0 and block B from 0 to 3,000 in year 5. And then year 9, we can do something similar where we turn off block B, which was at 3,000 in time step 5, and turn on block C to 3,000, and these 3 can continue on. Kind of makes sense? So if I look over in STSIM, and I could do all that, that's the wrong one. But if I was all done that, I could go back to STSIM just to show you, right click and import, go find that Excel file where I did all the editing. In this case, I'll overwrite them. And I can re-import those values. Why didn't it work?
I think you haven't saved the Excel file yet.
And it's still open.
That's what it is. Thank you. I have to save it first. There, it's brought over whatever I typed in Excel. So that's an easy way to do bulk edits, is to export, do your edits, and re-import. but that's not quite, I've only done it up to block 9 here. If I go over and look at my solution from earlier, it's very similar. It's got the targets set up like this. So here's all 6 blocks initialized in year 0, and then every 4 years it turns one of them on and the next block off. I mean, one of them off and the next block on, and the same thing in, in year 9 it turns one off and one on, so on like that. So if I run that simulation, which I already have, and add to results, I get this kind of a picture where it harvests block A for 3,000, then drops to 0. Block B goes up to 3,000, runs out of available area, but it tries. Block C harvests 3,000 acres per year and then starts running out. Block D runs out. So they're all running out, but they're all trying at least. And we're not harvesting where we shouldn't be. That makes sense? That was the answer to that question. Any, let me see, did I have anything else I wanted to mention?
I can confirm that what I did looks nothing like that. So I'll send you my table anyway, and you can have a look to see what I did.
Yeah.
Well, Stephen, I have banged my head against the wall on this transition targets because when I work with the mining industry, especially, we have really complex restoration treatments on these vast landscapes for mitigations for endangered species and all these time steps. And I have tertiary layers with different budgets and all that. It's just, it gets to be a very long file. So just to be safe, because I don't trust myself, I do the brute force in Excel. I cover all my bases, even including the redundant zeros. So don't worry if you, kind of lost it there or something, or you're not happy. Yep. I've screwed up on this one so often. It's just.
I mean, in the early days, we used to do a lot of preparing of these files in Excel, just like I did. These days, we do all our work, in our case, in R. So we'll script up, we'll create that CSV file in R, and once you're looping over things in R or whatever, you might as well throw in all those redundant zeros. Doesn't matter that you're ballooning up your file size, and you're a little safer, right? So a lot of these features for being parsimonious that you see in Synchronous kind of date back to the era when we were working heavily in Excel or even on the screens, right? And we wanted to not be putting in unnecessary zeros. Anybody have any questions or comments so far? I know we're a little over time. I was going to show you just, what did I have? I wanted to show, just wanted to show you an example in that Hawaii model that we had where just how we use strata there, just as a, again, a different real example. In fact, I'll show you tomorrow that the files you're working with in this exercise here come from that forest ecology paper. We're using just a 1/10 of the study area, but it is some of the things are changed, but some of that model is an applied model. But in the Hawaii model, we had we had 3 moisture zones as our strata, and if you look in the paper, you can see that's the wrong one. This one here. Somewhere there's a map of the moisture zones in Hawaii. Is it right here? So this is, the islands of Hawaii mapped into dry, mesic, and wet. So we were able to stratify our landscape according to those 3 zones. And then we were able to do some things like you did in this exercise where, for example, if you look over at that model now, if we look at the transitions, you go in here and we look at, say, fire. Let's find some fire in here. Let's see, fire right here. Let's see, there's the grass, forest to grassland. There's the forest fires. Let me see, no, they were driven elsewhere. Here's an example. But you can see that the dynamics, we have different probabilities depending on, actually in this case, proportions, but it's a similar idea. But based on what moisture zone you're in, we have differential probabilities in there. And then the other thing we did is we had in this model, this was the climate change effect we were talking about earlier. We had a transition, which is actually called moisture zone shift. And so we were actually able to shift the state of a landscape. Here's an example of this one here. If you were in a shrubland on the dry moisture zone, that cell might become mesic over time due to climate change and stay as shrubland, but this was a moisture zone shift of dry to mesic. And we had another external model that drove the rates at which these changes occurred. So somebody else did some other modeling to give us the rates, which we actually put in on another screen. I think they ended up in the targets. Yeah, here's an example. The dry to mesic shift, there is 8 square kilometers per year of moisture zone shift under this particular scenario that we're looking at here with climate change. So that's an example of how you can use the strata in a couple different ways.